Hi, and hope you are doing well. I'm Jody from Geeking Jody, and we are solving the top interview questions for programming. These are coming from the, as they call it, fine companies. That would be Facebook, Amazon, Apple, Netflix, and Google. Okay, Netflix is very complicated and big, but I'm not sure if it's in the size of Google. I don't know. Anyway, these are most important questions you should know about when going for programming interviews. So, we were solving the ones from arrays. We did a few. Now we are on majority. I found out that I have to solve more because faster, because these are 150 questions. If I upload every other day, that would be a year. I'm counting on Fridays not working. Anyway, so let's go for this one. Majority elements. Let's see what we have. Okay, it says majority element. Given an array nums of size n, return the majority element. The majority element is the element that appears more than numbers divided by 2. So the element which has the majority, remember, not the max, the majority. You may assume that the majority element always exists. This makes everything much easier. So we have an array which is 3, 2, 3, and okay, majority here is 3. We have another array here, 2, 2, 1, 1, 1, 2, 2, and the majority is 2 because we have 4 2s and we have 7 elements. So 7 divided by 2, that would be 3.5, and 4 2, so 4 is larger than this, so 2 is the majority. Always when you want to solve any questions, if you have any doubt, even if you don't, start creating a sample, trying to solve your sample, see how you solve it, then you can find the algorithm you've used. So I will go with 2, 2, 3, 3, 2, 1, 2, 2, for example. I can assume that I have 1, 2, 3, 4, 5 2, so it has the majority. What can I do? The worst solution will be have a 4 n in nums. So check every one of these. For any of these, check all the elements. So 4, for example, check in nums. Sorry, what's this? Check if your n equals c, add to some count. So you are counting how many 2s we have. I say I have a 2. I start with this 2. Okay, let's check everything. 1, 2, 3, 4, 5. Okay, I had 5. Let's go with this 2. I had 5. Let's go with this 3. I had this much. For every single element, you have to check all the elements and count how many of that one you have. This is very bad. We call this O n 2. This is very bad. I will speak about this later. But n elements, n to the power of 2, because for every element you are counting all the elements once more. You are going through all the iterating them technically. So this is not good. Never do this. Person who's interviewing you won't even wait for you to finish this. Okay, another solution. Another solution is HashMaps. HashMaps are very, very, very cool data structure in programming languages, especially in modern programming languages. All of them do have these HashMaps. In Python, we call them dictionaries. You can define them like this. For example, imagine I can start with an example about HashMaps so you can understand it better. For example, you have a HashMap of animals. In Python, we write it like this. Later, you see a cat. So you say animals cat equals 1. You remember, on arrays, for example, in this num, you could only have indexes. This was index 0, index 1, index 2, index 3. Here, you can have kind of indexes, but the cool thing is, if you saw a dog later, you can say animal dog equals 1. You saw another dog. You can check if dog in animal dog equals and sorry. You write it like this. Animal dog equals animal dog plus 1. If you had this. If you don't have it, you will get an error. But you can check with an if, for example, in a very, very basic mode. Good point about hash maps is when you say if dog in animal, with one lookup in the memory, the programming language will know that dog is there or not. Even when you say give me the value of dog in animals, with one pointing, it will read this. It doesn't need to go through everywhere. This is why we call it maps, hash mapped. It mapped to one place at a specific key. So it is very, very, very fast. This is the coolest thing about this hash maps. So how I can solve this using a hash map? I can go through all of this, save whatever I had in a hash map. So I can define something like counts equals a hash map if I'm in Python, and say, okay, do a for on this. For each of these, check if 2 is already seen. If not, say counts 2 equals 1. Go to the next one. 2, is it seen? Ah, yes. So add 1 to it. Make it 2. 3. Have I seen 3? No. So just do counts 3 equal 1. There is a nice shortcut in Python for this. You can write it like this. Counts n equals counts get n, so it will check the counts n or return 0 plus 1. This is a very nice method for writing this. You can say counts n equals counts get n, or if there is no n, return back 0 plus 1. So if you already had n, which is this, it will read that, otherwise it will add to it. This is a very nice shortcut. After going through all this way, so 3 will be 2, another 3, another 2, this will be 3, 1. Nice. So I can say counts 1 equals 1, this was 2, another 2, so this is 3, another 2, so this is 4 or 5 or whatever, if I counted correctly. At the end you can say, okay, this was the one with the most highest value. Is 5 larger than this divided by 2? If yes, return it. Although in the question says you may assume that the majority element already exists. So each time you are adding to it, I can just check if this is larger than the length divided by 2. I can return this. Let's write it. I want to do something fun. I will write it in Rust, which is a language which I'm not very good at. But the good point is you can write it later in what you prefer. Python is the easiest one. If you want to do that. So first I have to create a hash map. Let mutable. I will call it counts as we counted it. Hash map. What kind of hash map? It converts I32 key, maps one I32, which is a normal number, to a number. And it's in the form of hash map new. Should be this one. And you will see that I'm not very, very proficient in Rust, so I will do search. I don't know something, I will search for it. It's cool. 4. So I have my hash map, an empty one. I will go through all the numbers for n in nums. What I want to do, I want to read from this hash map and see if I had this. For this, in Rust, we have the entry. I already know. What I can do is search. So for this one, I can do, for example, Rust HashMap. Do a search, find the documentation. Always it's good to go to the main documentation, not the third-party interpretation of it, whatever. If you didn't understood it, you can go and search. But it's good to read the main documentation, especially on Rust, which is very good. It has a get. What does get do? Get returns a reference to the value corresponding to the key. Okay. Entry, I think, is what we need. Entry. Get the given keys corresponding entry in the map for in-place manipulation. This is what we need. And there is a nice sample. Letters. Entry ch. So read that specific one. And modify. Add one to the counter or insert one. This is exactly what I need. I would say. So this would be my counts. Counter is just a variable to add to one to it, or if it's not there, insert one. This is cool. This is exactly this. In Python, we would write counts equals a hash map. This we would write counts equal counts get which key. Here we have the n, or if it's not there, return 0 plus 1. So you can see why it's much more loved, the Python. So n. Now I have my hash map ready, but we can check this value directly here. If it's more than the total number of the noms in noms, return it. So I can here add another value, not to count it each time. I would say let total equals noms len as I32 to make sure that we are comparing apples with apples. Here I can say if counts get, we just checked it, n. I'm not sure how this works, but we can check again. Let's see how get works. Get returns a reference to the value corresponding to the key. Okay, it returns a value and it needs unwrapping. This is about Rust. Don't bother. Just see the algorithm. If count gets n, so it would be this because it's a reference here. Unwrap it. Get the exact value there. If it's larger than total divided by 2, return n. Nice. If nothing happened, return -1. We are sure that we have a majority based on the question definition, but in Rust I have to return something. So let's try this. Rust has great error reporting. For example, it says hash map not found in the scope. Cannot find type hash map. It says consider importing this struct. Okay, I need to import hash map. Next run. Accepted. So we will submit this. You saw what I did. You can do the same in Python and learn. Later. Okay, we are here. Very bad results regarding our speed. The point is, I'm creating another hash map and everything. There is a very, very cool but tricky solution for this based on voting algorithms. I will show it to you, but if you didn't get it on the first try, no worries. You have 2, 1, 2, 3, 2, 2, 1. For example, 2 has the majority with 1, 2, 3, 4 occurrences from 7, right? I knew this and I were not able to I believe I were not able to think about it by myself if I have never seen this. This is called voting system. We are sure that one of the candidates do have the majority, not the max, the majority. So if I start with 2 and say my candidate is 2, how many votes does it have? It has 1 vote. Okay. Here, oh, I have a 1. My new candidate, should it be changed? Yes, because 2 does lost 1 vote. So it has 0 votes. So this guy will be my candidate. So I will add 1 to the votes of 1. Practically, it's like asking everyone who is your candidate and change based on their answer. But after being sure that someone has the majority. So I would go like this. It's difficult to describe and difficult to understand, honestly. But think about it during night when you're having bad sleeps. You can think about it and go to sleep. This is my method. Okay, we will start. My candidate is 2 and 2 has 1 vote. I reached another person. This person voted for candidate 1. So now 2 has 0 candidates and my new candidate is 1. The next person votes for 2. So 1 loses 1 vote here, had 1 vote from this one. And again, 2 has 0 votes. So 2 is not my candidate anymore. I will choose 2 as my candidate with 1 vote. 3, another person. Okay, again this person, annoying one, voted for another person. So 2 loses 1 vote. 2 has 0 votes, so I don't have any candidate. 3 is my new candidate with 1 vote. Again 2, another person. So 3 loses 1 vote, 3 has 0 votes, so it's not my candidate anymore. 2 is my new candidate with 1 vote. Oh, another 2. Now 2 has 2 votes. 1 person voted for 1. Okay. 2 lost 1 vote, but still has 1 vote here because it had 2 votes. So my candidate doesn't change and 2 wins the election. Complicated, I know. But think about it. When you're going to sleep, think about it before sleeping. You will sleep very well. I cannot promise, but I hope. Comment if you were successful using this. Let me write it for you. So, let mutable vote is 0. Let mutable candidate at the beginning is 0. Okay. For n in noms, what we should do? Just what I described. If I would go with vote is 0. If I don't have any vote at the moment, I have to change my candidate. So, candidate equals n. My candidate is changed. This is the only one. Then I have to, am I right? It's complicated. But if I don't have any vote, I will change my candidate. Okay, right. If candidate equals n, vote is increased. Else, vote decreased. This is why what I described. We are moving on them. Whenever we see, we change them. Just the order is changed. And at the end, we will return back our candidate in Rust. You don't need this. Ouch. Might type be properly closed. Am I missing something? Ah, yes. Ah, no. And I don't need this hash map. Which one is not closed? Pop function here. Okay, this is the one. I had a 4. I have a if which is closed. I had if else. Huh? Ouch. Silly me. But we have a nice solution. Fuck. Candidate. Bad spelling. I'm tired, I believe, or I'm an idiot. But the point is, see how beautiful Rust error R's. It says candidate, okay? Help. A local variable with similar name exists, which is candidate. So cool. Accepted. Let's see where we will stand. We beat it 81%. Not that great. I was expecting much better solution. But anyway, this is voting algorithm.